Hello, I am Luis Nuño. I am a professor in the area of signal theory and communications at the Polytechnic University of Valencia in Spain. Now I'm going to explain why there are 12 musical notes. Western music is based on several basic principles. The most important one is, of course, the concept of octave and its division into 12 parts. This means that Western music is written with 12 notes. We can think of why 12 and not 8, 15, 20 or any other number. Apart from historical reasons, we are going to explain this fact from the physical point of view. Any real note produced by any real instrument has an irregular vibration. For example, here you can see a vibrating string, and we can see that the maximum is not at the center, it is on one side. And this maximum moves along the string with time, so this is an irregular vibration. It can be shown from mathematics that any irregular vibration is equivalent to a sum of infinite regular vibrations or pure tones called harmonics, and sometimes overtones or partials, but we will call them simply harmonics. Here you can see the real note and its decomposition into a sum of infinite harmonics. The harmonic one is called fundamental, and it has a lobe size which is the same as the real note. It means that the pitch of harmonic one is the same as the real note. The other harmonics have lobe sizes which are smaller than the real note. This means that these harmonics have pitches higher than the real note. Additionally, the intensity of harmonics 2, 3, and so on usually decrease with the number of the harmonic, and these harmonics determine the timbre of the sound. The timbre is that characteristic of the sound which allows us to distinguish a piano from a trumpet, for example. After harmonic 1, the most important one is harmonic 2. We are used to hear these two harmonics at the same time, so for us they have the maximum possible affinity, to the extent that in music we assign the same name to the notes corresponding to these two harmonics. The difference in pitch between harmonics 1 and 2 is called octave. The concept of octave is very intuitive. For example, if a man and a woman are singing the same song, usually the woman's voice will sound higher than the man's voice, exactly one octave, and we can perceive the two voices as perfectly tuned. Because we are assigning the same name to different pitches, we are establishing a periodicity in the note names, which leads us to represent the notes on a chromatic circle. In this circle, the notes with the same name are placed at the same point. For example, harmonics 1 and 2, 2 is double than 1, or harmonic 4, which is double than 2, or harmonic 8, which is double than 4. All these harmonics will be assigned the same name, so they are in the same point. Here we have represented the other harmonics up to harmonic 10. We can see that harmonics 3 and 6 are at the same place because 6 is double than 3, or here we can see that harmonics 5 and 10 are at the same place because 10 is double than 5. To know the exact position for these harmonics, we need a mathematical formula. Now we can think of in how many parts we should divide the chromatic circle. Because after harmonics 1 and 2, the most important one is harmonic 3. We conclude that we should divide the chromatic circle in such a way that one of the divisions is placed exactly at the same point of harmonic 3. The minimum number of divisions for that is 12. And this is the reason why we use 12 notes in the Western music. We can see that this division is not exactly at the same place of harmonic 3, but it's very near. For example, this division is not at the same place of harmonic 5, but it is near it. Once we have divided the chromatic circle into 12 parts, or 12 notes, we have to assign names to these notes. Assigning the names to the notes is made in a particular way. There are 7 notes which are called natural and the other 5 are called altered. The reason for this will be explained when we study the major scale. The natural notes are C, D, E, F, G, A, and B. And the distances between these notes sometimes is 2 divisions, like from C to D or from D to E. In this case, this distance is called a whole step. In other cases, for example, from E to F or from B to C, the distance is only 1 division and it is called a half step. When there are 2 divisions between 2 consecutive natural notes, we can include a new note in between them. For example, between C and D, we can include a new note which will be called C sharp or D flat. In the same way, between D and E, we can include another note which will be called D sharp or E flat. In a piano, the natural notes correspond to the white keys, while the altered notes correspond to the black keys. Here we represented the distances between 2 consecutive natural notes, W for whole step and H for half step. If we start playing the note C and we play the natural notes until the next C, we can verify that the second C is the 8th note in this series, and this is the reason why we call octave the distance between C and the other C, that is harmonic 1 and harmonic 2. The term octave comes from Latin language and means 8th. Once we have assigned the names to the notes, we can see which are the names of the first harmonics of any note. For example, for note C, its first harmonics are G, E, B flat, D. We can start with any other note, for example, from D, and we can obtain the notes corresponding to its first harmonics, notes A, F sharp, C, and E. These harmonics are given by this tool called the Musical Abacus. As conclusions, any real note has an irregular vibration which is equivalent to a sum of infinite regular vibrations or harmonics. The harmonic 1 is called fundamental and defines the pitch of the real note. The rest of the harmonics determine the timbre of the sound. After harmonic 1, the most important one is harmonic 2. We are used to hear these 2 harmonics at the same time, so for us they have the maximum possible affinity. To the extent that in music we assign the same name to the notes corresponding to these 2 harmonics. Due to this fact, we are establishing a periodicity in the name of the notes, which leads us to represent the notes on a chromatic circle. The distance in pitch between harmonic 1 and harmonic 2 is called octave. After harmonics 1 and 2, the most important one is harmonic 3. If we divide the chromatic circle in such a way that one of the divisions is placed at the same place as harmonic 3, we obtain 12 divisions, that is 12 notes. To assign the names to the notes is made in a particular way. 7 notes are natural and the other 5 are altered. The distances between 2 consecutive natural notes sometimes is 2 divisions, that is a whole step, and sometimes is 1 division, that is a half a step. The Musical Abacus, which is this tool I showed several times, gives us the first 10 harmonics for every note. You can find all the information on the webpage harmonicquill.com. Thank you very much for your attention.